So since we couldn't find any problems with the door components, we're going straight to the power door lock module. It lives right here. You take off the glove box, and we're back probed on the same two wires. Channel 1 is on the which one is that? The blue and white. That's the lock signal. And channel 2 is on the blue and yellow, the unlock signal. And we still have the same 11.4 and 5.1 volts on here. So next test I want to do is unplug this module and just do a resistance check on each signal wire to ground to make sure that there's nothing pulling down the signal, you know, like halfway. And that way we'll either know it's a module fault or if it's a wiring or component fault somewhere in the system. So that's the next check. Alright, doing a quick resistance check. This is channel 1 on the lock signal. Almost a million ohms, 0.9 mega ohms. And a quick check we can do just to make sure. We'll press the button over there. Let's see which is lock and unlock. There, that's lock. 1.0 ohms. Release the button. Mega ohms. There's no short to ground on the lock. And the one that was low, the unlock, second channel, 10 mega ohms. We press the unlock button here. 1.1 ohms. Release. 18 mega ohms. No short to ground, or 1.9. So we're down to the lock module, the door lock module. This red box right here. This thing. When we plug it in, we don't get a good signal. You can see the pin numbers in there. So 10 is lock, 11 is unlock. 11, on pin 11 we only get 5 volts instead of 12. So we could slide this guy apart, see what's going on in there. The magic red box, made in Japan, Toyota. This is the original unit. Alright, it's plugged back in. We're still at 11 and 5. Let's pop this guy apart. So super easy to take off the little cover and the whole shebang slides out. I wish all modules were this easy to mess with. So let's see here. Pin 10 and 11. 11's our culprit, and so that's the bottom row, and it's going to be the 1, 2, 3, 4, fourth pin in on the bottom row. 1, 2, 3, 4. That guy goes 1, 2, 3, 4 on the bottom. You can look over here. That's going to be hard to point out. That guy right there. And well, we can poke around the multimeter, see what's going on with that guy. So I did a visual inspection on the module. I didn't see any cracked solder joints. The only thing we can do is monitor our voltages and kind of do a little flex test on the board and see if we can bring this thing back. But otherwise, I'm calling this door lock module. I'm kind of surprised that it would come down to this. I think it would be a simple switch problem, but yeah, I'm just going to bend it around and see if we can do anything to this signal. You can see the two relays there, lock and unlock. So it's a control side issue. It's not a load side issue. But the owner said he doesn't lock his car ever, and he just wants to disable it. He just doesn't want the car to lock the keys inside. So you could just leave this module disconnected. That'll be you know, for the owner, that'll work. Or we could go to the junkyard and try to get another one of these. I wish I could fix it, no parts required. But we can see which, you know, pin the unlock where it goes to, which component. And I traced it a little bit. It goes to these bigger resistors, and one's 12 and the other one's like 4.5 volts. So it doesn't really make all that much sense to me anyways. So I can poke around here a little bit, but I think we're pretty much done. A little bonus footage. Got a test light connected to ground. I kind of traced the lock and unlock circuits. So right here we have a power feed to 2 resistors, and they go through another pair of resistors to this control chip. And you can see traces on the other side of the board. From here they go to our lock and unlock signal. So we can be the switch and ground either this one. So that would be the let me see here, unlock, or we can ground the other resistor and it goes to these 2 pins. That's lock, that's unlock. Okay? So let's backtrack a little bit. That's unlock, that's lock, that's lock, unlock, lock. Okay. See that? We follow the trace. So I'm sorry, these 2 resistors. This is the lock and this is the unlock. Well, when it unlocks, it automatically locks again. And the voltage on these 2 pins should be the same. Let's see, what did I do with my there we go. So I'm gonna try to focus you guys in on this, on the scope and the board at the same time. It might be a little difficult. Let's go like so. So comparing the 2, in one we have 5.17, and the other one we have battery voltage about 11.4. I think they should be the same when we're not energizing them. However, on the one that's problematic, on the unlock, we have, you know, the 5.1 right now. Why is that? Well, we can go to these 2 resistors again. Let's see, get a good contact there. 5 volt, and on this one we have battery voltage, so not good. And then on this side we have, let's see here, 5 volt and 6.2. So there's a voltage drop across, I guess, the known good from 11.4 to 6.2. On the known bad, it's 5 . 5 here, and 5 here. I don't like that. Again, battery voltage 11.4, and on this side 6.2. That's the good one. The crazy one, .4 there, 6.2, 11.3, 5.3. So there's no voltage drop across this resistor. Why is that? That's what I want to know. And we can even go to the chip. There's 5.2. And on the next pin over, the known good is 6.2. So in this circuit, can we say which component is bad? Can we say? Because the resistors right here, there's a common, battery voltage, so they're good up to here. Then once they go across these big resistors, on one of them, it drops from 11.5 on one side to 11.4 on the other. That's our known good. And on this one, it drops from 11.5 to 5.1. Now, is this a resistor problem? It could be. Resistors do go bad. Is it one of these small ones, or is it the chip? So let's do a little poking around here and figure out which one of these components is actually bad. Because if it's a resistor, we can just put a new one in, not a problem. Alright, this is kind of neat. So let's measure the voltages again. So we're starting at 12 on both resistors. This is the known good. On this side, it's 11.4, and it goes to this guy, 11.4, and drops to 6.2 on the chip side. So let's write those numbers down and compare them to the other one, which starts at 11.5, drops to 4.9, says 4.9 and 4.9. There's no voltage drop across this guy. There's a big voltage drop across this guy, even though it doesn't make any sense. This is like 0.6 kilo ohms and this is 47 kilo ohms. Something is wrong with these resistors. So I drew a little summary of our situation. So we start with a common 11.5 volts, and we go through the first resistors here. So let's start with the good one, the lock. We have 11.5 volts before, 11.4 after the first resistor, and then 6.2 after the second resistor. So this resistor is a higher value. On the bad one, we have 12 volts, or 11.5 here, 4.85 after the first resistor, and 4.9 after the second one. Weird, right? So the lowest voltage on this leg is actually in between the resistors. So we're back to something is pulling down this control pin. That wire, the control wire that goes to pin 11, off the module to our switch. So this guy right here, pin 11, goes to our left-hand power door lock switch, unlock and lock. We measured the resistance there as mega ohms. So what the heck is going on? Is there something else on the board that could be spliced into here that's pulling this whole leg down? Let's take a look. Alright, back to the GeoPrism door locks problem. Took a few days off. Merry Christmas, everyone. Time to come back with a fresh head. And what the heck is wrong with this thing? As you remember, we're going towards the door lock module problem. However, for the life of me, I couldn't explain why on the control wire. Let's go back to the wiring diagram. It's actually a very neat problem. So this door locked and unlocked signals, that's where we're having the issue. Remember, the door lock signal was a clean 12 volt, and you push the button and it pulls it down the ground. However, the door unlock signal was hovering around 5 volts, very weird, and every time you activate the locks, the signal would jump up to 12 and come back down to its weird 5 volt level. So that's not supposed to happen. This is only should be based on the button, not anything else. So what the heck? And this right here, this time lapse, is when the timer energizes the lock or unlock relay. So then it's kind of like, hey, how is the power, going to the actuators, making it to the input signal going to this module? That right there is key. It exactly coincides with the module activating or deactivating the locks. And I mean, this is screaming that there's 2 wires somewhere that are touching or shorted together, not completely, but enough to, when we have power on the going to the actuators, it actually, goes up to 12 volts and then comes back down to 5 when everything is deactivated. Very interesting. So I'm like, you know what? On this module, our problematic door unlocked signal, I want to measure the resistance from here to one of these pins, 3 or 4. And those are the actual power feeds that go to our motors in the doors. So let's go to that connector and measure the resistances. So here we are at the connector, and I'm measuring the resistance from the problematic door unlock signal, pin 11, the blue and yellow wire, to the blue, the fat blue wire going from the, let's see here, the blue is a door lock relay. And we could also measure from the red, and keep in mind, this is a complete circuit. It goes through all of the door motors, and I'm not about to unplug each one. We don't really need to. All we want to know is that input signal, the door unlock input signal, that's the only thing it's supposed to go to is this button. That is its only purpose in life. The other door, we don't even have a switch on there, so this is not used. Remember, we found a little green crusty on there. That was not our issue. But this guy is only supposed to go to the button. That's it. My theory is, since we're getting the high 12 volt pulse on there when it's not supposed to be tied in, when the relay is energized, somewhere in here it's shorting out to, there's not a complete short, since if it was a complete short, that green trace would actually drop to 0 because these things right here, by default, they are grounded. And when you send power to one, current makes it through and grounds through the other relay. And then backwards. Power through here, grounds through this relay. So when the system is not energized, both of these are going to ground. So resistance reading. Resistance is 240 kiloohms. I think that is way too low. It should be infinite. So, what do we do? Where do these wires come close together? Where could they possibly be shorted out? Well, on each door, the door harness comes in here and plugs in to these, bulk connectors. You can see the big blue, the big red, and all the control wires are in here. So this is for the passenger door. So I did a little wiggle test. For wiggling here, the resistance doesn't change much. We could even unplug this whole thing if it'll cooperate. Let's do this with 2 hands. We'll watch our meter at the same time. So let me unplug this guy right here. Okay. Didn't change, right? 240 kiloohms. Just doing a visual inspection. This thing looks, there is a little green something or other in there, but otherwise the terminals look pretty clean. And looking inside of here, yeah, it's not ideal, but our resistance didn't change. Let's go to the driver's door. Same picture here. Now these wires are a little damaged because there was some kind of alarm system installed here years ago. But when I started wiggling, the resistance on my meter started going up and down a little bit, which is a big clue. So I'm just wiggling this harness. I already unplugged it actually. Let's see, I plug it back in. 144 kiloohms. Look at that huge difference, like 100 kiloohms difference. 220, 230, plugged in about only 140. I don't like that. And this one is even greener, so that's not good. Let's see our wires. The yellow and blue, that's one we're worried about. And on this side I can definitely see some green, and right next to it is the blue. And I think if we're lucky, the problem is right between these two wires. So if we kind of spread them apart, look at our resistance. The green in there is definitely not good. So if there's a current path from here to here, it'll actually start pulling this wire down. That's why we're seeing like 5 volts instead of battery voltage. This wire is powered on all the time. Even when the car's off, all the time there's voltage on that wire. And if it's making it to either the red or the blue, that's not going to be good. I mean, look at all that green stuff in there. So try to clean this connector up and see if that short disappears. We can even try to take that pin out and hopefully make this resistance go way up. I think we're getting really close to the problem, because that would match our symptoms and this. When that relay is energized, the actual input wire goes up, and then when it goes down, the locks activate again because that's an input. So the output and the input are like crossed. So let's play around with this connector a little more. I think we're very close to finding the root cause of the problem. Alright, so I have our scope connected. Channel 1 is that blue and yellow wire, which is supposed to be a 12. It was at 5. And the other channel I connected to one of the power feeds to the door motors. It's the, I guess, the blue or the red wire. Doesn't really matter. But I think just messing with this connector, we already potentially fixed the problem, which was channel 1 used to be at 5. The unlock relay. Let's plug this connector back in, see what happens. See what happens to our yellow trace first, and then we'll play around with the locks and see if there's any feedback. No change. So when we press unlock, that should ground out the yellow trace. And press lock. I think we fixed it. Now the yellow trace, which is the unlock signal, pulled clean to ground, release the button, so there's no more feedback on that trace from the relays. Lock. I think that's about it. If we wiggle the wires, now that trace is at 11.2 instead of 5. So that right there, I'm saying, was the root cause of the problem, the green crusties. This trace was getting pulled down to you know, the actual blue or red, I guess the fat blue wire that feeds the lock actuator in the driver's door. So inadvertently, by playing around with it, you know, we could have the scope hooked up and then played around with it, would have seen the control voltage on the input rise back up to its normal state. The fix is to spray all this stuff with deoxit, and hopefully, you know, the water or whatever, a little moisture got in there, and over 20 years it caused this problem. So there isn't necessarily a water leak in there, but it's just kind of a bad environment and the connectors aren't sealed. So pretty cool case study, I think. Even on this system, it's not the module, it wasn't the actuators, it wasn't the switches, it's just some green crusties in a connector by the door pillar. Awesome. Thanks a lot for watching. Hope you learned something new about the diagnostic process. In this case, the scope was actually very handy to see the relationship between the input and the output. You know, your desired user input and the control, and they were actually crossed together. That's why we saw the 12 volts, you know, spike, and then back to this weird 4 to 5 volt kind of partial ground, we'll call it, through the green crusties. So I think the owner will be happy to have his power locks back and not have his keys locked inside the car again. And that's it. Thanks a lot for watching. See you guys next time. Bye-bye. A little bonus footage. Inside the blue female plug, you can see the green crusties. Let me, right in there. You see that? You see even the dust on the pins, and the pins themselves are definitely in not in good shape. So we'll have to clean this guy out. Oh man, lighting in here is a little tight, but there you go. So deoxit time, and this thing will be good as new.